Okay, the step to assess the potential for the losses. We are talking about the leak off, yeah, maximum. We don't want to leak. Okay, the leak. The worst scenario is you have a loss by the fracture. The potential for losses depends on the several factors indicated in the prognosis. Fracture gradient versus planned mud width, presence of the known loss zones, fault zones, differential pressure sticking area that we have like a high permeability, overbalance drilling in the weak formation, and sudden change in the fracture gradient. Step to assess the potential for loss must provide the data from the subsurface prognosis. We talk about the prognosis with predictions. Prognosis means that has the data that have uncertainty, so not 100% precise. There is a range for that. You need to look at the upper limit, lower limit. That's called the prognosis. Including the estimated pore pressure and estimated fracture gradients. This is not the real, because we have this fracture gradient, we have only the shoe, yeah? Yes. We have some data point and we do, for example, curve fitting or past the curve. This is not 100%, that's why we estimate it. KCC depths and any information regarding potential losses or weak formation. By analyzing this data, we can determine the depths with the lowest fracture gradient, which will dictate the maximum allowable mud width. Maximum allowable mud width for the next section. Calculate the maximum allowable surface based on the fracture distance at the K section. And identify interval where the planned mud width might approach or exceed the fracture gradient, or where known losses zone exist, indicating a higher potential for losses. Look at the well control. The management of dangerous effect caused by the unexpected release of formation fluid, such as natural gas or crude oil, open surface equipment, oil or gas deliveries, and escaping to the atmosphere. This is going to be all related to the keep loss, fracture gradient, pore pressure, that's going to be directly affected on the well control. If you look at the well control, now we want to see, okay, what is the well control? We have a primary well control, we have a secondary well control, and we have a tertiary well control. Primary well control is the use of, we talk about this hydrostatic pressure, yeah? Use the fluid to prevent the influx of the formation fluid into the well. Secondary well control is the use of BOP system. All, including all, not only the BOP, common unit, all the connection, leakage, choke, manifold, everything. Forwarding, all coming together. All the degasser, we need to look at all together. And tertiary well control, which is going to squeeze back, cementing, relief well, yeah. Look at the primary, yeah. Process which maintain a hydrostatic pressure in the wellbore greater than the pressure of the fluids in the formation being drilled, but less than formation fracture pressure. You need to be in the window, yeah? Window, the lower limit is going to be pore pressure, upper limit is going to be fracture. Wonderful. Use mud weight to provide sufficient pressure to prevent an influx of formation fluid into the wellbore. Okay, this primary well control include drilling fluid with adequate density, active system volume are continuously monitored. Okay, we need to see, okay, what's happening for the mud. We have an active system and we are circulating. Okay, the increase is gonna be gain, if it decrease is gonna be loss. We need to make sure that we fully understand. Sorry?
Optimize.
Might be optimal. Changes are dictated immediately and correct actions are being performed. Any increase in the flow, we need to stop and go for the flow check. If the flow check, we have flow right away, we need to shut in the well. There is no any, and then inform the supervisor. This is the job of driller. I believe two people are very important in the rig. One is the driller, one is the mud engineer. The rest, like a rig manager or tool pusher or the company man, they're gonna, for example, manage the operation. But to execute in the right time and the correctly, these 2% are very important. And usually, still I do not understand why are not mud engineers well paid? Like for example, directional driller, because they have very difficult job and very important job. But very critical, but they are not well paid, yeah? They are not their level, like for example, directional driller or what?
I think he's the first person who blamed something.
Yeah, they are, it's a very important. I think, how they, they do many things, yeah? And they are very busy actually. There are lots of inventory preparation, many people, local people, also contaminations, loss, flow, everything. It's like a blood. Yeah? They are controlling the blood in the body. And this blood, if this blood is healthy and treated well, whole well is healthy. This is all I think. But still, I do not understand why are not paid well. And I don't know. Okay, about this FIT, this is the essence of the formation and the shoot. We are not talking about the leak of this, yeah? That fracture gradient. Test the essence of the formation. Maybe asking the question, yeah? If you look at all the sample example, you will see. Test essence of the formation and shoot by increasing bottom pressure to design pressure. You want to go to the next formation to say, okay, it is okay that we can continue. First, we check the shoe. Okay, we're gonna increase from 10 to like 12 ppg. With the 12 ppg, you're gonna hold the pressure or not. Ensure that formation.
Mohammed,
Yes.
we can't get this information from leak-off test?
Leak-off test, for sure. When we have leak-off test, already we have FIT.
Yeah.
Because FIT, we just want to increase the pressure that for the next section. We want to see, okay, if I'm going to go, for example, right now in the 2000 PSI, 2000 feet, 2000 meter. I want to go to 3000 meter. And I know that I have to, based on the plan or program, I need to increase the model from 10 to 13 ppg. What I do with the FIT, I'm using 10 ppg and apply the pressure, surface pressure, and make equivalent model of 13 ppg at the shoe before drilling. This is the FIT. Okay. When I do this one, I say, okay, the plan, I'm double checking the program. It is working or not. But when I do the leak-off, the purpose of the leak-off is not for our job. It is for geomechanical study. They want to find a minimum horizontal stress, maximum horizontal stress. It is not working for us. We have a fracture. They're gonna use this fracture gradient for the casing design, for the mud window, but not for the current operation. For current operation, I need FIT. It's enough. When you do the leak-off, you are using the leak-off for the later, for the next program. They are updating. Any leak-off you are making, they put it in this fracture gradient prognosis. More leak-off is become more precise, less uncertainty. But for current operation, I need what? FIT to go to this one.
It's for determining the maximum allowable.
Yeah.
So you are just double checking because if you are currently already done leak-off test in another well or near well, and then you design the program
We
depending
need to
on
make sure
that.
that's the work. Yeah.
So you're just double checking by FIT, right?
Exactly.
And usually, the leak-off test is performed at the beginning of the first 10 wells in the field. By the time when the field, for example, for Hellfire field, for mushroom formation, we know the fracture for this. We performed many times before at 2015, 2016 and finished. Nowadays, only FIT performed. But for a new formation, for example, Yamama or others, if we need to get more information, we perform the leak-off test. Like this, just to know as Mr. Mohammed said, the whole geomechanical information, the stresses for this one, and to design the mud window based on the leak-off test for the whole field.
You know, this is the problem. When you go with the leak-off test, you fracture. Yeah? This fracture may because the formation is not as now when you frac it, maybe not integrated anymore, and you cannot continue. This is a challenge. You are inducing a fracture. If you're inducing this fracture, maybe you need to go and cure this one, put the cement, and you cannot continue. This is a whole problem for them.